resonance. We see it in the vibrations of a hard bass, and we even say that people who get along well resonate with each other. Let's think of a guitar. It has two E strings. If I pluck one, the other one vibrates too. This is because they have the same resonant frequency. The vibration of one prompts the vibration of the other, and the other's response identifies it as an E string. Now, what about resonance on a smaller scale? Say, a quantum scale. In nuclear magnetic resonance, to resonate a nucleus, we don't use guitar strings, but instead a varying magnetic field. Varying just means it has a frequency, like these waves, and also like the waves of a guitar string. The frequency of the applied field must match the nucleus's frequency. Think back to the guitar. It is a specific note that engages the other E string. You can also think of it like a children's puzzle. Only one specific shape can fit, just like only one specific frequency can engage the nucleus. When it matches, the nucleus is engaged and reoriented along its axis. Think of spinning a basketball. The ball acts as the nucleus, and my hand, adding more spin to the ball, acts as the magnetic field. When I spin it, it wobbles and spins faster along its axis. So, we disturb the nucleus from its relaxed state by applying the magnetic field, which makes it spin full of energy. So the nucleus responds to this reorientation and energy by emitting an electromagnetic signal. Think of how we breathe. We take in oxygen and we let it out as carbon dioxide. The nucleus takes in a breath of energy, so now it's full and needs to release, and it lets it out as the EM signal. The signal is like the atom's signature, and we can use this signature to identify it. However, the magnetic fields of NMR are bulky, and the expanse of the field cannot help have unintended effects on surrounding atoms. It's like I'm playing Jenga. I want one block, but I ended up knocking the whole tower over. I still got the block I wanted, but I got a lot of others in the process. Now, what if we could resonate atoms with something other than a magnetic field? Something very localized that allows me to pick out one block, affect one atom. Nuclear electric resonance uses an electric field to interact with the nucleus. The electric field, like the magnetic field, must be varying at a certain frequency. Like NMR, this interaction reorients the nucleus and prompts the electromagnetic signal. So, NMR and NER are basically two different methods of accomplishing the same thing, like sending a message through mail or through text. One is clearly more direct, but both accomplish the same goal. So we can use resonance in the guitar to create harmonies, and also in atoms for identifying compounds, quantum computing, and imaging. As Shao Kahn once said, the biggest breakthroughs start with an insight, a new way of looking at things. The switch from using a magnetic field to an electric is truly a new perspective